Hello, my beautiful students. Today we'll be talking about some key features of a square root graph. Now, before we dive into the specific key features, what we're going to do is expand on transformations just a smidge. And what we're going to do is we're going to look at a graph that has already undergone its transformation. So it's already moved left, right, up and down, reflected, and or has stretched vertically or compressed vertically. So the graph you'll be seeing is the graph after it has moved, and what we're going to do is we're going to come up with an equation based on how the graph has moved. So once we know the transformations, it will be very similar to examples 4, 5, 6, and 7 in the previous section where after describing the transformations, we built an equation. All right, and you should have a piece of paper that contains these 4 graphs to help you mark on your picture. I think it will be helpful if you mark on your picture the things that I'm going to show you in your picture. Well, let's get started on our first example. So again, everything I show you on the screen, make sure that you mark it on your own picture. Well, let's get going. So whenever we identify the transformations, it's always good to see, well, where did the graph move away from the parent function? So it's always helpful to draw in the parent function. Now, I just kind of did a brief sketch. Again, the parent function, we usually use the points 0, 0, 1, 1, 4, 2, and 9, 3 if you want to be more accurate. All right, so this is our parent function, which it's really helpful to know the start point on the parent function, which the start point on our parent function is the point 0, 0. And then you can see, well, where did the start point move to? And that will help you kind of figure out, well, what transformations are going on. Okay, so in our newly transformed graph, the start point is at the point 3, 0. So if my start point was 0, 0, what has to happen to go from the point 0, 0 to the point 3, 0? Which direction did this move in? Well, it has to move to the right, and it moves to the right 1, 2, 3 spaces. So this graph is moving to the right 3 spaces, which remember, if we move horizontal or left or right, that is an h value. Okay, so all we're going to do is in our standard form of a quadratic, we're just going to fill in the appropriate h value. Okay, so the h value is whatever is added or subtracted to the x. Sorry about that, you guys. But it's whatever is added or subtracted to the x. And remember, don't forget, you must think the opposite with the h value. So if we're moving to the right 3 spaces, we're tempted to say plus 3 because we're headed in a positive direction. Well, we are going to say minus 3 because we think the opposite. Okay, so the equation that represents this newly transformed graph would be the equation y equals the square root of x minus 3. So there you go for example 1. All right, now example 2. Again, it's always helpful to start from the parent function. So I just drew in a brief sketch. Again, it's the points 0, 0, 1, 1, 4, 2, and 9, 3. And again, you guys, most of the time it's helpful to start from your start point and to know what that is to figure out, well, where did the new start point end up? Okay, now before we talk about where our final start point is going to be in our transform graph, first of all, it's very obvious to see that the graphs are not facing the same way. Like this one is facing upright and it's increasing, while the newly transformed graph is facing upside down and is decreasing. Okay, so first of all, the graph had to flip upside down, which if you remember, which value will cause the graph to reflect over the x-axis? Holy hot dog, that would be the a value. Okay, so when it reflects over the x-axis, this will affect the a value. Okay, so we know it's reflecting over the x-axis. Okay, and then after it reflects, then your start point, which the start point on the reflected graph is still 0, 0. But then after that, your new start point is at the point 0, 2 for your reflected graph. Okay, so after we reflect, in order to get to this point from the point 0, 0, what do you do to the point 0, 0 to get the point 0, 2? Okay, well, you have to move up 2 spaces. And sorry, guys, let me fix this problem before my computer dies. Sorry. Okay, so to get to the point 0, 2, we have to head upward. And we're going to head upward 1, 2 spaces. So if we head up and down, don't forget we think kangaroo, which is a K value. So it moves up 2 spaces. Okay, so in our standard form, which I'm going to write down here, this will affect the A and the H value. So A and K value. So let's talk about this one at a time. Okay, so when you reflect over the x-axis, do you remember what kind of A value you're going to get? Whenever your graph flips upside down, that is when your A value will transform into a negative. And since we don't have any other A values, your A value is simply going to be -1. Or if you want to be a lazy mathematician like most mathematicians, you can just throw a negative sign out in front. So whatever floats your boat, you can put -1 or simply a negative sign. All right, now the K value, we don't think the opposite. So since we're heading upwards in a positive direction, our K value is going to be a +2. And don't forget the K, we add on to the end. So A is the number right out in front of the square root. The K is the number added or subtracted onto the end. So your equation that represents our newly transformed graph is the equation y equals negative or -1 times the square root of x and then +2. All right, let's get going on example 3. If you want to try example 3 on your own, I encourage you to do so. Otherwise, let's get going. So again, here's our parent function. It's good to note the start point, which the start point is at the point 0, 0. Okay, and then my new start point on the final graph is the point -4, -2. So you need to think, well, what can I do to the point 0, 0? To get the point -4, -2. Well, if you see here, to get over here, we have to head to the left, and we're going to go left 1, 2, 3, 4 spaces. So we move to the left 4 spaces, which don't forget, when you go left or right, think horizontal, which is an H value. And then we have to go down 1, 2 spaces. So when we head down, remember, we think kangaroo up and down, so it'd be a K value. So we're going to move down 2 spaces. So in our equation, the H value and the K value is what will get affected. So the H value is whatever is added or subtracted to your X, but don't forget, you must think the opposite with the H value. So if we're headed left 4 spaces, I know that's a negative direction. I know, you guys. Okay, but we think the opposite. So since we're going to the left 4 spaces, it's actually going to be a +4. Okay, and then the K value is the number that's added or subtracted onto the very end of your equation. So since we're heading down 2 spaces, we don't think the opposite with the K, so it would simply be a -2. And that would be the equation that represents your transformed graph. All right, you guys, example 4 is going to be a little different than the other ones. So I would like for you to watch and follow along in example 4. And guys, it's going to be awesome, so get excited. I can already see how excited you are on your faces. So let's get going. Okay, so again, it's always good to start from the parent function. Okay, now if you're looking here, this graph looks like it's kind of being stretched upward. Like if I were to grab this, I can't grab it on here, but if I were to grab this point right here and move upward, the graph would kind of stretch upward like this. Okay, do you remember which value stretches the graph vertically? Holy hot dog. That would be the A value. So we know that A value is somehow getting affected. Now, the graph is not moving left, right, or up or down. So your start point for both graphs is going to remain 0, 0. So looking at the start point for this graph isn't going to help you. So I'm going to look at another point to see, well, what is happening with my parent function points to get to the A value point. So I'm going to pick the point 1, 1. Okay? Now, I want to pick the point on this graph that relates to this point. So I want to know when x is 1, what is y on this graph? So the point I'm going to look at is when x is 1, which is this point. If I go up, I land right here when x is 1. Okay, now to get to y, it's kind of hard to see on your graph what y is because it's kind of all blurred together right here. So we're just going to approximate. It might not be perfect, but I'm going to draw my own tick mark. So I'm going to count up 1, 2, 3, 4, and then lastly 5. So 1, 2, 3, 4, 5. So I'm approximating this point to be at 1, 5. Now, it might not be perfect, but that's what we're going to go with since we don't have an actual graph to look at. We just have this printed graph. So it'll be close enough though. All right, so I'm going to say this point is at the point 1, 5. Now, if you remember when we graphed transformations, we had a table, and when you had an a value, what you had to do is you started with your parent function point, which the point I'm only going to look at on the parent function is the point 1, 1. And then, well, didn't mean to do that. Sorry, guys. Demon Cat's got me. But anyways, when we graph transformations, remember we took our parent function points and then we simply multiplied the y value by the a value. Okay, so if I'm looking at y, what do you multiply 1 by to get 5? Well, 1 times 5 is 5. Okay, so I'm going to assume that the a value in this equation is 5. Okay, so we're going to say the graph is vertically stretching by a factor of 5, which is an a value. So that means the graph is 5 times as high vertically as it was originally. Okay, so that is the only transformation that has happened. It did not flip over the x-axis or move left or right or up or down. Okay, so only the a value in my equation will be affected. Okay, so the a value is the number right in front of the square root, and the a value, since it's vertically stretching by 5, and since we had to multiply by 5, the a value would simply be 5. So you're going to throw that 5 right in front of the square root, and so your equation for vertically stretching the graph by a factor of 5 is y equals 5 times the square root of x. Bam! So there you go, you guys. That's the equation, and that's it for now.